Hi, my name is Morten, and in this video we will be taking a look at search in Ucommerce. So search is the ability to define exactly what properties and how you want to search in the Ucommerce APIs. All of it starts at our index definition that we have already taken a look at. And this is where we have the ability to define what goes in the index, how it goes in the index, and thus also how we can search on it. Out of the box, Ucommerce indexes all the default properties. We have been talking about that a couple of times, but this is particularly interesting to see how they actually store the different properties in Ucommerce, because that defines also the ability to how you can search, namely, for example, full text search, fuzzy search, and so on. Let's take a very quick look at the decompiled version of a default products index definition. So here we can basically see in a very nice decompiled version that Ucommerce stores almost all the different properties related to having data in your indexes, and thus also how you can search on them. For example, display name, short description, and long description are all stored as full text, which means that you have a better way of searching full text on those. Whereas if you have SKU, variant SKU name, and the definition as well, you have a less advanced way of searching. You could, for example, search with literals and stuff like that. And that's what we will explore in the APIs in this exercise. We already have a search bar implemented on the storefront, and we have a product search controller that we can use in order to do the actual search. And that's what this exercise is all about. So let's take a look at that before we dive into the actual code. We actually don't need to change anything in our index definition here. But if we have a custom property that we would like to search on, that could, for example, be if we want to refine our search based on a certain custom property, then we would have to define it in our index. We can actually already search for color, tag, fabric, description, and so on. But if we want to have them in a special way for full text search, then we have to define that in the index here as well. We don't need to touch this for now, but you can play around with it in case that you would like to do something custom or more advanced, just for the fun. Otherwise, we can just follow the exercise here and get a nice sense of how to do the actual search when it comes down to translating a user query into actual code. So that's what we will do here. The search is very simple, implemented on the website. We enter our query in a text box and we extract that as a query string parameter, which is basically a text that the user will enter, and then we do the search. So nothing fancy, just the ability to search on different properties using what has been entered by the user. We have a bunch of stuff already pre-implemented because we have covered much of this territory anyway. So we have a map product method down here that takes all the properties similar to the product listing page and map that. We have already taken a look at that, how to do the URLs, how to do the prices, sellable products, variants, so on and so forth. We also have catalog library. We have URL service and catalog context as well. These are mainly being used for the mapping. Here we need to use a component that are a little bit lower level, which is the actual access to the search index. Our catalog library as such allows us to grab categories, to grab products based on the context and what we pass in, but catalog library itself does not expose the actual search API. We have to dive a little deeper into the abstractions of Ucommerce to do that. Which is also what catalog library uses in order to find products for a category, for example. All of this is built straight into the lowest level component that integrates with the search APIs. So let's extract that into our controller in order to use it. So let's try to resolve the actual index from the IoT container. We have tried that a bunch of times before already. So we have to use the object factory to grab it. In this case, the type that we want to get out is ucommerce.search.iIndex. And the iIndex has a generic parameter, and that's the model that we are using also in all the other places, which is the search model product. And generally speaking, these are the models that we are exposing out of the box with Ucommerce. You can also define your own and get that out here if you want to. In this case, let's just stick with the default implementation. Alright, so this is the type that we are looking to use. Let's call this index, and then grab it from the IRC container with Ucommerce infrastructure object factory instance.resolve ucommerce.search.iIndex of ucommerce.search.models.product. So now we don't have any doubt whatsoever what's happening here and what namespaces to access. Okay, so we have the index now, and now it's actually time that to use it to do the actual search. In this case, what we can do is we can call index.find, and here we can do a projection of the model as well. So if we want to get another model out, then the Ucommerce APIs will automatically map those for you. In this case, I just want to stick with the default one. Which is our product. So this defines what we can do in terms of type safety as well, because we can search both on soft keys, so we can index into the model and say we want to search on this particular field, or we can use the type safety of the platforms and the models in order to do the actual search. So we can do both things. When we get a .find method, we get back an interface or a Fluent API called iSearch. It has a single method called where that we can use. So this sort of feels like a regular link expression that you will build up. We have branded as not link. And that's because we don't want to expose a complete link interface for you. We want to support the common scenarios also, so we have the ability to better control the actual performance of your queries and your access to the index. So it has a narrow but very powerful set of things that you can do. It supports everything in terms of search, which we're looking into right now. With the where clauses, so there's a few different techniques we can use here, and of course it also allows you to do orders, to grab a list, just as a single object in the search, so the top one for example. It also allows you to do facets, so here we can actually combine our search query from the user with facets as well. We can do skip and take for pagination, which is already happening in the default implementation out of the box. So it actually limits the result set that we get back. So we have to explicitly say to the API if we want more than I think it's 300 in our result set, not to change the performance of the website. So skip and take and pagination or endless scrolling, whatever you want to call it, is built straight into the APIs for your safety. So that's a very relevant piece of information that you need to know about when you start using these APIs, that typically you want to take this into account. It's fairly straightforward just to use the skip and take functionality. In this case, we will not worry too much about it. Here you just see that you have the ability to do so, and then you can start to model and play around with it when you have a larger data set that you're working against. So let's try to explore the actual where clauses, which gives us the ability to insert a facet dictionary. We passed that into the catalog library when we did the facets part, and the catalog library is actually just passing this into the same API that we're using now. So we have sort of used both abstraction. This is the lower level abstraction, whereas catalog library sits on top of the I index that we are working with right now. So if we are combining, we have to pass in a facet dictionary as a where clause here as well. Otherwise, we have the ability to set up an expression similar to what you do in LINQ. So here I can do a lambda expression and say I want to search, for example, on long description. Long description is indexed as full text, so I can do full text search on that. The way that we do this is not via a simple literal. We can do that. But in this case, we want to control how the actual queries are built up. So we don't want to always do full text. We have to explicitly say that. We also explicitly have to say if we want to match with a literal expression or if we want to match with wildcard, because the underlying implementation determines also via performance how that's going to work. So instead of passing in a literal straight like this, which we can do, then it will just search with literal. We have this construct here called a match class. So match is a model that we expose under ucommerce.search. And this is to tell the API what function we want to use. It has also previously been implemented as extension methods on the string object, but we don't want to pollute the string with something that are specific to the search namespace. So that's why we decided to create this match class here that you can then pass in, and then when Ucommerce translates your lambda expression, it will be translated into the correct search in the underlying search provider. Out of the box, Lucene and Elasticsearch. So I can do match.fulltext here, and in this case I just pass in a single string, and in this case it's the search term that came from our per-string parameter. So that's the free text search input field that we have on the front end, and I just want to pass that in like this. And then it will actually allow me to do full text on this long description. But when we search for something in via free text, we of course want to match on different things. So we want to match in the description of the product. Do we have any results in there? We want to match on the name. We want to match on the SKU. We want to even match on the display name, or if you have any custom properties, you can match on those as well. So here it will basically just be simple ORs that we want to put after this, similar to what you do with LINQ. If you do where clauses and do another where clause, you will combine it with where and where. Those are both these expressions needs to be matched up. In this case, I am doing a single where clause where I match with or. So it has to match long description or whatever other property. Fairly straightforward. Should not come as a big surprise how that works. So I want to match on name as well. In this case, I could choose to do a literal directly. So if I search for iPhone, it has to match that. But if I don't know how to search for iPhone, maybe I just type phone. So I want to either do a fuzzy search or a wildcard search. So the star search where it says in either of what comes before or after. I can do that. So in this case, I'll do a match.fuzzy, and it takes in an input. Again, it's my search term. Search term. and then I can give it a distance of up to two swaps. This is the underlying algorithm that does this. It basically says how many characters do I need to swap in order to get to my result. So if I misspell something with a single character, then it will be able to match that with my fuzzy search. It goes up to 2 in distance. Then it does not try anymore. Then it will fail to find it. In 9.4 and 5 going forward, all searches are case insensitive, which means that if you're doing fuzzy searches, then the distance that you're searching for will not take casing into account. Otherwise, it would have to use one of the swaps to change a uppercase to a lowercase, or the other way around. That should of course not be the case, because the user should be able to do the casing however he wants to better give him a nicer search experience. And then we also have boosting built into the APIs, which means that in some cases I'm interested in boosting certain search terms above other properties. So that could be, I would like to see my search for iPhone. I would rather find actual iPhone, so I want to boost on the name rather than the description. For example, a phone case, where it says in the description, in this this phone case supports iPhones and iPads and whatever. Of course, I don't want to find the accessories for an iPhone before I actually find the iPhone first. So there's a ranking going on here that you can take into account in the APIs. So that's the fuzzy search. Let's also try to do a literal. So I want to do a literal search on SKU. Here I just pass in match.literal. And my search term again. And last thing that I could do would be to do match on the display name, for example. I want to match on a wildcard. And I take a decision here that I want to not let the user enter the wildcards himself. I will define that it has to go anything before or anything after is enough. Of course, I have to then take into account if the user searches with stars himself. I could create some functionality that removes stars from the search input. So that's actually it. Here I just facilitate the search using the different techniques that the API offers in order to find my results. Let's break this up a little bit so it becomes a little more readable, depending on what the eyes that sees. So I do where, long description, name, SKU, and display name. So either of these needs to match. If I want to combine this with facets, then I pass in my facet dictionary, which is the user's input for what he has already selected. In the first go, that will be an empty dictionary, of course, but then once he starts to take off different properties that has been matched with facets that we defined in the product index definition, then here we can combine free text search with actual facets. So we pass that in here, and then of course if we want to support skips and takes, then we pass that in afterward. We want to skip the first 100 and then we want to take 100. So it's fairly straightforward, and this would all of this would probably be something that are familiar to what you have done already. The only difference is that it looks like LINQ, but it's in reality it's something that we have designed that looks like LINQ and behaves like LINQ, but it has a much more narrow scope, but it allows you to do all the crazy advanced searches that you need for your web shop. So last thing that we can do, we can call to facets. So if you do facet search, there's of course an overhead associated with that, which means that if you don't want to use faceted search, you can just call to list directly, and then you get back your list of results. It has a total count, which means that for this search, how many do we actually have in the index, and what is it that I see right now? Remember that we had skip and takes, so you would always have a maximum of 300 if you don't define anything. But if you have a match of 100,000 results, then that's what you will see in the total count. And the result is what do I actually load up in my list here right now. Of course, if you have 100,000 search results, then you may want to tell the user to narrow his search a little further. Otherwise, we have the results right here, which is the list of products. So here we have the results. Let's populate that to our model by calling map products. Like this. Again, this down here, the map products and the get search term, this is basically a boilerplate code that needs to be there in order for us to do the actual search. The important bit is what we do in our controller here. And that's it. We don't have to do anything else. Let's try to compile the solution and see if it works. Okay, so my site is back up and spinning, and now I can actually start to search for the different products that I know I have in my store, so we can see the different types of searches in action. So the first thing that I can do is search for support, because I know that there's a product here with the name support. So one thing that I could do here would be to type PPO, and that would still find support because that's the wildcard search in action. I search for a phrase that exists, and on both sides of the search term there's something there, so support will naturally be found. I can also search for support with a misspell. So instead of support with a T, I misspelled it with a D, and still find support. And I also have in my my long description of one of my products, which are using the full text search. Let's go in and take a look at that in the back office. So here I have the text awesome. This shirt is so awesome that you will not want to miss out. So let's try to search for the word awesome. So it actually finds my shirt one because it uses full text search. And if I misspell awesome, it will not find it because it's not using fuzzy for full text searches. So there's different search techniques that calls for different ways that you want to do your searches. So sometimes it will use full text search. Sometimes you specify to use fuzzy, and so on and so forth. It really depends on how Lucene stores the data in the index, on how you can actually search, and that's what we defined in the index definition. So that's basically search in a nutshell. You have seen all the APIs. Now it's time to try it out yourself. We also have great documentation for the different search types and how to actually configure it. So I hope you enjoyed the video, and see you in the next one.